Hi. The basic motive behind this video is to give you a brief idea of the problem statement as well as our work. So, COVID detection using only cough sounds from a bird's eye view looks like a binary classification problem. But actually, if you see, so there are a lot of challenges involving the crowdsourced nature of the data, then again the highly varied COVID negative class, and so on. So our contributions here are particularly in pre-processing, then again the feature space, and finally modeling those features. So processing. If you see, there is a lot of non-uniformity in the duration of these audio files. Now, this is because in some of these files, audio events apart from cough sounds have also gotten recorded. So this pre-trained audio event detection model is trying to localize the cough-related regions in these audio files. So as an output, what we are getting is a data set that is much more consistent in terms of both the duration, audio content that is more relevant to cough sounds. Talking about the feature space, so besides the temporal and spectral features, we are also looking at the temporal variations in the spectral dynamics of a cough signal. On top of that, what we find is that when we fuse all these three, the temporal, spectral, and tempo-spectral features, we get a much more robust feature set. So that is the MDR. So that is the multi-domain representation. That's the basic fusion of all these three features. Coming to the modeling part, we need to understand that COVID positive is one big cluster, which is say the samples that are coming from all COVID positive patients. COVID negative, on the other hand, is samples that are coming from healthy as well as people with some other diseases. So within COVID negative, there are smaller clusters. So it has been seen that in data learning approaches, particularly here we are talking about triplet loss. So these have been shown to be much better at learning the intercluster as well as the intracluster information compared to supervised architectures. Now, to summarize this, so we see that the cough event detector is able to give us a much more consistent data set. Then again, both the multi-domain fused feature set as well as the contrastive learning based approach. So both of these give us a much better performance compared to a baseline approach that would have been trained using only the MFCC features. So I hope this was interesting. We'll have a much more detailed discussion in the poster session. So hope to see you there. Thank you.
Thank you.
Okay. Hi.
Could you? Hi. So let me start off by asking. Oh, actually, there's a question from the audience already. So let me go ahead and ask that then. The question is as input to the fully connected layers. Oh, I'm sorry. No, that's from the last talk. Let me go ahead and ask then. Could you say a little bit more about how you trained the cough detector, the acoustic event detector that you used to endpoint the cough?
Yeah. So this pre-trained, this is a pre-trained model, that is the YAMNet. So this has been trained on the audio set ontology. But the thing is, from the pre-trained model, we don't only look at the cough sound event, but also audio events that are much more similar to cough. So for example, there is cough, then again there is throat clearing. And the interesting thing is, if you look at the ontology of this, like the YAMNet model, right? So then the audio events have been designed or have been placed in a hierarchical structure. So whatever are the subgroups that are present or sub audio events that are present around cuff, so we also consider those. And one more thing to add is like, for example, see plop, the PLOP. So is a audio event that is not actually like a related to cuff, but in the acoustic sense, it is much more related to cuff. So even though if the model detected it as plop, so we still considered it as a positive sample to be taken as for our future experiments.
How did you decide which of those sounds were similar and which were not? So, for example, how did you decide that plop is similar enough to cough to be considered as a cough?
Yeah, so this like particularly this observation was based on the empirical analysis. So we found that although there were some samples in which cough was detected, but still the model was detecting it as something other than coughs. Like for example here plop. One more thing is like this particular model looks at only 960 milliseconds of windows. So like only based on the 960 millisecond of a audio file, it will try to give out the probability in terms of the individual audio events.
Okay. There's Sriram is asking, do you have any performance metrics to indicate how well the cough event detector works?
So this particular model has been trained again on the AUC, the YAMNet model. And in our case, what we are doing is, so again, once we get the probabilities from this pre-trained cup detector, so we again like base it on the basis of what are the durations of the region that have been detected. So there are two types of region that we detect. Either it is cuff or cuff related, or everything that is else. So that is the other region. So if in case there is a audio file which is say 10 seconds, but only between say first like say 0 to 2 seconds we found cuff, then again from 2 to say 6 seconds there was some other, and then from again 6 onwards there is some like the cuff related region. So we split that audio file into two different audio samples with both marked as whatever is the original label. So actually here we come out, so if I am not wrong, so we had a total audio files of 1040, and then after the splitting performance, so we get around 1073 audio files.
Okay, I see. It's quite complicated actually, because each file might contain more than one instance of cough.
Correct.
Okay. Thank you. I guess we'd probably better move on to the next talk. So thank you very much.
Okay, thank you.